Hey, how are you liking them 3x3 systems of equations? Maybe after this lesson, you'll start to develop feelings for your calculator, kind of like I have. So, we can use a matrix to represent and solve a system of equations without even writing the variables. What is a matrix, you ask? It is not this kind of matrix. It is a different kind of matrix. A matrix is a rectangular array of numbers. Usually, we display the array within brackets, like this. Sometimes you'll see it with big parentheses, but normally you'll see it with brackets. Alright, so matrix A has 2 rows and 3 columns. So we call it a 2x3 matrix. Each number in the matrix is called an element of the matrix, and you can identify a matrix element by its row and column, like so. This little a, 1, 2 means what is the element in row 1, column 2? And row 1, column 2 is 4. So remember, it goes row, then column. Row, then column. RC, like a remote controlled car. Row, then column. Alright, so what is element 2, 3 in matrix A? Well, here's matrix A. Row 2, column 3. So row 2 is here. Column 3 is 1, 2, 3. So row 2, column 3, the element in row 2, column 3 is 8. So what is the element A1, 3 in matrix A? Row 1, column 3 is 17. Alright, so you can represent a system of equations efficiently with a matrix. Each matrix row represents an equation. So this row would represent an equation. So the last matrix column shows the constants to the right of the equal signs. So the equal sign would be right in between here. Okay. So if you have this system of equations, x plus 3y equals 7, 3x plus y equals negative 8, it would be this matrix. The coefficient is 1, 3, 7, so 1, 3, 7. 3, 1, negative 8, 3, 1, negative 8. And then we can draw a vertical bar here to just remind us that that's where the equal sign would be. So, how can you represent the system of equations with a matrix? So we got to remember that the coefficient of y is 1 and the coefficient of x is 1. And then we can just plug it right into our matrix. 2, 1, 9, 1, negative 6, negative 1. Coolio. How about this matrix? We have to remember that it goes x, y, and then constants. And then if we have 3 variables, it's going to go x, y, z, line, constants. So, how's this going to look? First, we need to write each line of the system with the variables lined up in the correct order. So x minus 3y plus z equals 6 is already good. X plus 3z is really, you got to think about this as x plus 0y plus 3z. And then if we subtract 5x from, or add 5x, add 5x to both sides of this equation, we get 5x plus y equals 1. But we have to remember that that's 5x plus y plus 0z's equals 1. And now we can just plug that into our matrix. The coefficients are 1, negative 3, 1, 6. So 1, negative 3, 1, 6. 1, 0, 3, 12. 1, 0, 3, 12. 5, 1, 0, 1. 5, 1, 0, 1. So that is how we represent a system of equations using a matrix. So, how can you represent the following systems using a matrix? Pause and see if you got it. Okay. So how would I represent this as a matrix? Well, I got my coefficients, negative 4, negative 2, line 7, 3, 1, and negative 5 on the other side of the line. For this one, I got 4x minus 1y plus 2z equals 1. And then I got, so here, I'm going to rewrite this over here. we got 4x minus 1y plus 2z equals 1. And then in the second row, I've got 0x plus 1y plus 5z equals 20. And then on this one, I'm going to have to add y to both sides to get that on the other side of the equal sign. So that gives me 2x plus 1y plus 0z's equals 7. So how would we represent that as a matrix? 4, -1, 2, line 1 for the top row. The second row is 0, 1, 5, 20. 0, 1, 5, 20. And then the bottom row is going to be 2, 1, 0, 7. So that is how we would represent this system as a matrix. So is everybody honky-dory with that? Cool. So that's your secret code phrase for today, honky-dory. Alright, so what linear system of equations does this matrix represent? Well, we're just going backwards now. Each row represents an equation, and it goes x, y equals the constant. And then these are the coefficients. So 5x plus 2y equals 7, 0x plus 1y equals 9. So we can just simplify and write the system. 5x plus 2y equals 7 and y equals 9. So pause and see if you got it. Alright, so this is x, this is y, this is the equal sign, and this is the number. So we got 2x plus 0y equals 6. 5x minus 2y equals 1. So 2x, we can simplify. This is 0y. 2x equals 6. I can actually simplify that too and call that x equals 3, but I'll just leave it as 2x equals 6 for now. So 2x equals 6, and 5x minus 2y equals 1 would be our system of equations. Now why would we want to express a system of equations as a matrix? Well, because we can do row operations, kind of like how we would do substitution or elimination, actually. And eventually we can get a matrix to look like this. And if you think about what this means, it means x, 1x plus 0 equals a. So this really means x equals a, y equals b. So if we can get our matrix to look like this, then we know that these two numbers are the solution to our matrix, to our system of equations. So row operations are like this. You can switch any two rows. Okay, you can just switch spots. You can multiply a row by a constant. So if we multiply the bottom row by 2, it becomes 2 times 2, -1 times 2, 3 times 2. We get 4, -2, 6. You're allowed to do that. You can add one row to another. So we can add row 2 to row 1. We get 3 plus 4, 2 plus -2, 5 plus 6. We get 7, 0, 11. And you can combine any of those steps. So we can solve this using a matrix. And remember, I hinted at calculators at the beginning, and there will be calculators. So just relax. So first of all, we need to write this as a matrix. So boom, there's our matrix. 1x plus 4y is -1. 2, 5, 4, 2, 5, 4. Okay, so now I just mentally want to run you through these steps before I show you how to do it on the calculator. Multiply row 1 by -2, and then add that to row 2. So when I multiply row 1 by -2, I get, let's see, I get 2 times -2 times 1 is -2, -2 times 4 is -8, -2 times -1 is +2, and then I add to row 2, so -2 plus 2 is 0, -8 plus 5 is -3, 2 plus 4 is 6. Why did I do that? Because now I have a 1 here and a 0 here, and remember my goal is to get a 1, and then a 0 and a 0. So what can I do next? I can multiply row 2 by -1/3. What good would that do me? Well, when I multiply row 2 by -1/3, I get 0, 1, -2, which gives me a 1 here. Now, if I can only somehow get a 0 there, well, I can. I can multiply row 2 by -4 and then add that to row 1. And then replace row 1 with whatever I got. So, here is row 2. I'm going to multiply by -4, which gives me 0, makes this -4, and makes this +8. So 1 plus 0 is 1, 4 and -4 is 0, -1 plus 8 is 7. So now I can replace this with the top row. And now I'm done because I got 1, 1. I got x equals 7 and y equals -2. So the solution to the system is 7, -2. Now I'm going to show you the good stuff. How can I solve this using a calculator? Well, this format that we saw before, this format right here, where you have 1s on the diagonal and 0s everywhere else, is called row-reduced echelon form. You don't have to know that, but row-reduced echelon form is what it's called. That'll be meaningful in just a second. Now, if you don't have this calculator, or one like it, you can look on the home page, and there's a link that you can get this for your computer. Now, what I'm going to do is I'm going to enter this matrix into my calculator using this matrix, second matrix. And then I'm going to go over to Edit, and I'm going to edit matrix A. And it's going to be a, let's see, it's R by C. So rows is 3, columns is 4, so it'll be a 3 by 4 matrix. And then I'm just going to start entering in my values, so my coefficients. So I'm going to go 2, 3, -1. Now make sure you use the negative sign, not the minus sign. -1 and 1. And then I got -4, 9, 2, and 8. So -4, 9, 2, 8. And then I've got a -2 for A, a 0 for B, a 2 for C, and a 3 for my constant. Alright, so now my matrix is entered in there. So I can do second and then quit to go to calculator land. And now, if I click on my matrix button again, and now I go to math, I'm going to go down until I see row-reduced echelon form. Hit enter. Row-reduced echelon form of what matrix? So I'm going to go to matrix again, names, 1, I want to do it for A, so I'm just going to hit enter, and it'll put A in there. And then I'm going to hit enter, and then it'll put it in row-reduced echelon form for me, which gives me my solutions. And now if you don't know what decimals go to what fractions, 0.5 is 1/2, 0.6 repeating is 2/3, and then that's just 2. So it's 1/2, 2/3, and 2. So we got A equals 1/2, B equals 2/3, and C equals 2. Yep. All right, so see if you can solve this. Grab a calculator and see if you can. Okay, so I am going to go back to second matrix. Edit. I'm going to go ahead and just edit matrix A to have my new values in it. So I've got a 1 there, a 4 there, a 6, and a 21. Then I've got a 2, a -2, a 1, a 4. I have a 0 for A here. Got a -8 for B, a 1 for C, and a -1 for my last one. So now, if I quit, now watch, I'll be sneaky and I'll just go back up here and select row reduce echelon form of A again, And now it'll give me the answers for the new matrix A, which is A equals 1, B equals 1/2, C equals 3. Didn't your life just get easier and more magical? All right, talk to you later.